Before we get started disabling effects in the game, let's go ahead and take a quick look at another HelixMod feature that we're going to use extensively in the future. This is going to be a simplified version of this particular feature, but this should be a good introduction and give you enough information to be able to use this on your own. In the HelixMod DX9 settings.ini file, we can add constants. Constants are just any number that we might want to actually use in the pixel shader or the vertex shader itself. -1, 0, 55, 55%, anything that you can think of can be sent in from the dx9 settings.ini file to the shaders. The idea being that the .ini file can be edited easily and still change the effect of the pixel shader and the vertex shader by the actual numbers that they use at that moment in time in the shader. So this gives you all kinds of flexibility. For example, we could actually use the constants to change where the HUD is actually located in the depth. By, say, putting in the number 80% and passing it down into the shader, we can put the HUD at 80% depth. Or we can make it pop out by making it -10% depth. We could specify how transparent the HUD might be by changing the number in the dx9 settings.ini file. We can make it 50% transparent or anything that we prefer. These constants can also be chosen based on a given key press or a mouse press and have different characteristics. So they can toggle, they can be an on-off type switch, and can have the same sort of an effect down in the shader where the actual constant that's being delivered changes based upon the key press or the mouse click. So for example, that's very good for changing the viewpoint of a character using the F keys. We can also change the convergence to 0 when the right mouse button is held down, and that's used extensively for iron sight aiming, for example. So that's the kind of stuff that you can do when you have constants that can be delivered from the dx9 settings.ini file. This will become a little bit more clear later on, but it should be pretty obvious after we do our little experiment here of what you can use these constants for. Okay, so now what we're going to do is, in our case, it's going to be a simplified version of it, but we're still going to use the key press to actually change characteristics in the shader. And what we're going to do here is we're going to make an on-off mechanism where we can decide in each shader whether to show the original shader or our disabled version. So the idea being that this will be a toggle. You press the numpad 0 key by default, and we'll toggle it from being the broken version, which we start with, to a disabled version, which is our fix. This will give you an easy way to take a look and see how does it look and whether or not disabled seems like the right call or not. There's no particular advantage to doing this. There's nothing that it actually enhances the gameplay, but it's interesting and it makes a great demo, so we're going to do it. And it also makes it easier to decide whether something needs to be fixed or whether having it be disabled is good enough. And that'll become more clear later in the lesson as we use this feature to compare and contrast the broken version with the real version and try to decide whether we actually want it disabled or to leave it in place as something that we actually want. Okay, we're going to go ahead and get started with creating this on-off mechanism using the HelixMod constants. So let's start by editing the dx9 settings.ini file. And one thing we're going to do is set dump all equal to false for speed purposes. Let's go ahead and find the actual directory using our handy shortcut. We knew we were going to come back here all the time. Here's our dx9 settings.ini file. We open him up, and here's what we have so far. Our use rendered shader is true, and our dump all is equal to true. Go ahead and line this up so it's a little cleaner. Now, we're going to go ahead and comment out the dump all because the dump all is really only used for a single time. It'll dump all the shaders. There's no particular value in dumping it every time the game launches. And of course, by doing that, it actually slows down the launch. So we're going to comment that out. It won't have any effect on the dumps folder itself. They'll still be there. We can still look at them. But this keeps it from actually dumping them every single time. So that's the idea there. Okay, so that's the basic idea for that guy. Now that we have pointed out that particular thing, we're actually going to replace this entire file. So let's do the next step, which is we're going to look at the next default dx9 settings.ini file we're going to look at. So let's open this in a new window. And I'll drag this over here so we can actually see what's going on. So now this is going to be what we're going to replace the contents of the dx9 settings.ini file with. And the reason to do this is because we're adding this new feature of the constants. In setting it up, is a little bit of a trouble, and it tends to be a little on the fiddly side. So we're going to copy and paste this as opposed to trying to type it in. It's very easy to make typos that are very difficult to understand and figure out what happened. So we're just going to go ahead and take all of this, which is the actual contents of the ini file, copy it. Now we're going to switch back to our notepad, and now we're going to go ahead and select everything in this file and just replace it with this new version. So I'm going to go through some of these details here to give you an idea of like what's happening with this, but this will be our new dx9 settings.ini file as it goes. And you can see that we are going to use a slightly different technique. Rather than comment it out, we're actually going to say dump all equal to false. In general, it's slightly better to, if it is a true-false variable, go ahead and use false because it's more clear than having something in the front of the line there which kind of blends in with comments or other stuff. So dump all is going to be false to give us a slight speed advantage there. Now, use rendered shaders is going to be true. We'll pretty much always leave that on unless we have some sort of a problem. And you can see I've added some comments here to give you some explanation as to what these parameters do and why you might want to use them. So in general, we'll leave use rendered shaders true. It's always useful because trimming that list of shaders for hunting is almost always good. The only reason to not leave that on is if we get crashes during hunting or possibly some other problems. But that's relatively rare, but some games you end up having trouble if this is on. Okay, dump all is off, as we noticed before. Those will still be available so we can search those files at any time. Okay, let's go on to the next section here, which is the constant registers that are going to arrive in the vertex and the pixel shaders. So this is just a definition of what number to use. And so we're just going to use the default vertex shader constant and the default pixel shader constant. Both of these I'm going to set them to 250. There's no particular reason to use any given number here. The maximum number is 256, but Helix tends to use 250 for this particular thing, so we'll follow his lead just to match the documentation and other examples that you might see. Since there's no particular advantage, we'll go ahead and use that. The only time you might change this number is if you have a conflict with something in the game itself. That's where the dump all might actually come in, is if you get something that's not working, you could actually look in the dump all to see whether C250 is actually being used already in some shaders. Then you might want to change these numbers. But if there's no conflict, we'll stick with 250. Now in the vertex shader, this will come in as C250. You might recall that we had C0 and C1 in our shader file before. This is the same idea, but it comes into the shader as C250. There won't be a definition for it, but it'll still be available for use. Okay, that's just a definition, nothing too significant there. Now the next thing on the list is a preset keys list, which is what keys will be used. And when I say keys here, I actually mean this key down here. This is a definition of a key list. And this one is telling the HelixMod debugger how many of these key operations that it can expect to see. In this case, there's only one. The semicolon at the end is critical. So in general, when you're doing this sort of stuff, copy and paste something that's known to work as a starting point and then modify it. If you try to write one from scratch, you tend to miss stuff like that semicolon and those things, and it causes you some lost time. So this is just another definition. So it's key list. This can be as many as you want. There can be 2, 3, whatever you want, but then you would actually define these key lists down here, and that would change whatever key happened to be. So maybe F5 key for changing the viewpoint, and then the O key for changing transparencies or whatever strikes your fancy. For us, though, we're going to go ahead and leave it at 1 because we only need 1 for our simple purposes. And now this is the actual main thing. This is the actual key operation that we want to specify. And in this case, it's a single one. And what we're going to do is we're going to use the number pad 0 on the keyboard. And that key equals 96 here, which is the definition for that. This is one of those strange Helix things. All of these keys are specified by decimal numbers, even though most of the other stuff happens to be hexadecimal. This one's a decimal number, and in general, you'll go ahead and use the keys here as specified. Now, there's one thing that's worth taking a look at here. I'll show you in our default dx9 settings.ini file, I've added some references down here at the bottom to actually make some of this a little bit more clear. So this is a Microsoft Virtual Key Code. So if we go to this link, for example, we look at it in the new tab there. These are the key codes where we actually find the magic number that we need to put into the dx9 settings.ini file to choose what you want. So if you want to use a control key, you'd put in the number 11 once it's converted from hexadecimal back to decimal. If you wanted to use the escape key, it would be 1B converted back into decimal, and so on down the line. This gives you all the different possibilities for strange keys, things like insert, F1 keys, F11, that kind of stuff. Control keys, unusual keys, num lock, scroll lock, insert, that kind of stuff. Okay, now if it's a normal key, you could just use the regular like ASCII column. So we'll open this guy in another. This is just an ASCII key, and the ASCII keys are any sort of normal key. So if you wanted to hit the O key, for example, down over here we have the O key, and the number for it in decimal is 79. So in the ini file, you might actually change that number to a 79 if you wanted this to be the O key instead of the number pad 0. But it's your choice. You can choose anything you want. I'm just trying to give you an idea of where to find those magic numbers to put into this key specifier. Okay. Now the other key part here is that this decides what the presets are going to be. This is another list that can be anything you want. It can cycle through 4, 5, or 6, however many you want. We're going to cycle through 2 items right now, just presets number 1 and number 2. And that actually is these presets down here. Preset 1 and preset 2 is the same specification here. So the idea is that when you press the numeric 0 keyboard key, that it chooses the next preset in the list. So it starts at preset 1. We'll start with this crazy number. Then if you press the number pad 0 key, it'll switch to 0. If you press it again, it'll go back to 1. So it'll be alternating between these two. This number is 1.0 in floating point hex, and it's 0. So it'll be switching between 1.0 and 0, sort of like a true, false when we cycle through those things. If that's not clear, by all means, ask us questions in the forum, and we'll try to explain it a little bit better. Type 1 here in the key list, this is means that it's a toggle format, so it'll toggle between these different types. If you make this a type 2, then it's a momentary type switch instead, so you have to hold the key down in order for it to have effect, in which case it'll switch back to the original one once you let go. That's obviously good for iron sight type aiming operations, but in our case we want it to actually be a toggle. Okay, hope that's clear. Now these constants are the ones that are specified here, and the constants are nothing too significant except that they are floating point numbers. And it's a little weird to define a floating point number in here, and for some reason we'd have to define these in hex instead. So the way to find out what your hex numbers are, going back to our page here in our references. So if you want to do a floating point to hex converter, we would go to this particular page as a reference, and you can put in whatever value that you want to convert it to hex. So for example, we want to make it 1.0 because that's a sort of a normal convention for a Boolean true. So in this case, it would be the 0x3f8 so on, so on, so on number that is actually in float. If you wanted to make this to something else, like you wanted to make this 50% as a 50.0 number, then you would convert that to hex and put in this crazy number instead as the constant, and that will get delivered to the shader for you to use as a percentage of transparency or whatever you might want to do. I hope that's clear. It's a little weird, but that's the mechanism you use to convert regular numbers into these hex constants, so that you can pass these into the shaders. Now the reason these are floating point numbers is because at the shader level it only knows about floating point numbers. It doesn't know about sort of regular decimal numbers. Okay, so those are our constants. We're going to switch between 1 and 0, and it's going to be passed into the shader. Now one tricky bit here is that this is constant 1, and there are 4 of these constants that you can use: constant 1, 2, 3, and 4. And the different variants are the different pieces of a float 4 that's passed into the shader. So const 1 is C250.x. const 2 would be c250.y, const 3 would be c250.z, and const 4 would be c250.w. So it's the x, y, z, w for the different like numbers there. And that's only useful if you want to have multiple ones of these constants. You could actually have extra constants here. So for example, we could put in const 2 equal to 0x00000 if we wanted to. And that would actually get assigned at the same time. So you could use both of those at the same time. So you can specify multiple ones within the same piece right here. Also worth noting in this particular preset list, you can change the convergence, the separation, and a couple of other things. That'll become more clear in later lessons as well. So now you could use const 2, and some people use const 2 all the time because on occasional games apparently there are conflicts with c250.x, and so c250.y is apparently slightly more safe, I guess. So just keep that in mind. If you're getting some sort of a strange failure, you might want to switch that and use c250.y. But for clarity purposes, I'm going to stick with const 1 because it's easier to keep track of if we don't switch all of these parameters around and get all of the pieces mixed up. So const 1, c250.x when we're actually in the shader. That's what we're going to go with for now, and we'll see whether it works. So that's the pieces for the new dx9settings.ini file, and I've left the comments in here to try and give you some better idea of like what's going on. This particular sequence is not well documented elsewhere on the web, especially this new format for the preset key lists. So this will probably be some of the preliminary documentation for this. Okay, hope that's clear. If not, ask us questions. No doubt we will try to answer them. Okay, I'm going to go ahead and save that because saving it is good if we want to actually use it. Okay, so that's the basic idea behind the dx9settings.ini file. We're going to go ahead and now actually see how that's used in the shader file itself. So let's go ahead and find the A977 text shader. That's our ball shader, if you recognize that number. That's the one that's the heinous bloom on the light that we actually disabled before. So now let's go ahead and find that file. Go ahead and zoom these guys down. We know that we can get our ball directory here, so we go into the shader override, which is where our shader is, and we're in pixel shaders. And in here we have a pixel shader that we've got a 977. This is our one. Bring him up. This is our annoying bloom on ball light. Should look familiar. Now as we scroll down, here's our line where we actually fixed the effect by making the effect disabled. Okay. So now we're going to go ahead and bring our guy back up. So now this is where we're going to use those constants that we just made. So now in the definition section, we're going to add a new piece, and at the bottom we're going to add this other like code piece down here. And just for reference, I left this over here as well in the DX9 default settings. So this is how to use the shader code here. So this is a little piece that you can find. So I'm going to go ahead and copy and paste this piece here and put that into the notepad. Okay, and we're going to actually put this in the definition up here at the top. So I'm going to go ahead and paste that in, and we're going to make sure we're going to put a little space around these things just for clarity purposes. So this has to be after the Pixel Shader 3.0 definition, which starts the entire process. And it could be anywhere within this definition section up to here, but it can't be past the declaration section because of the way that the assembly language works. So we're just going to go ahead and paste these in here, and you can see that we're going to leave these constants. I'm going to leave this constant in here, and we're going to outdent this code like I mentioned before in order to make it clear what we've added versus what's actually the original code. And I like to separate things by white space so that it makes it even more clear where we've added something and what's the original code. Now I'm going to change one thing here. I'm going to change this language of this file to be C. It's not actually C, but that makes him actually do better notation and lets you see what's constants, or sorry, what's comments and what are actually like variables. So that bit sometimes makes it a little bit easier to see what's going on. Okay, now this comment right here actually doesn't mean anything. I just put that in because I like to have a lot of information to remind me of how things work and to save me time from having to like remember like what happens. So for example, if I put in this definition that we're going to use register C250, then we know that that's coming in by magic from HelixMod, but there actually is no definition for it here. So that's sort of inconvenient because I like to have things declared so that I can remember. So I'm putting this in as a comment as a reminder that C250 does in fact come in, and it comes in from the DX9 settings file as these constants. Now, this is const 1, const 2, const 3, const 4 as a reminder that it's X, Y, Z, W for those different pieces. So no, again, no particular requirement to do that, but I like to keep things out of the mysterious category as much as possible, primarily because when you get something strange happening, it's very difficult to figure out what's going on. So get in the good habits early, and you'll find that you'll save yourself time in the long run. Okay. So now the next one that we're going to add is the new constant itself, and this is register C200, and this is one that we're just going to create from scratch. And the reason to use this one is that we'll use this constant in the future as well. This magic 0625 number here will become very useful later on, and we'll just start with this as being our sort of default constant register to use. Okay. No particular reason to use 200 again. In Helix's most recent fixes, he uses 200. It's a nice round number. It doesn't seem to conflict with other stuff in other shaders, so that's good enough for me. So C200, the first parameter here is going to be 0. This is going to be the number that we're actually going to be comparing against the C250, and the reason to do that obviously is because that's the X parameter, so let's compare it with the X parameter of the C200 and the 250 themselves. A 1 just for fun because we might need it later, our magic stereo texture number, and then our 0 number, which you actually use to disable effects just like we did before. Now before we were using this C1 0 parameter, the C1 dub. It's okay to use that, and we could have used it in this case as well, but we're going to go ahead and create our new constant and use these as we go forward. Okay. Okay, we have our constants defined the way that we want. So now we're going to go ahead and use those constants in the actual code down below. So let's go ahead and scroll down to our section. Here's our original statement where we actually used the C1 dub, which is 0, assign it to the output color register to disable that effect. So we're going to replace this line with an if statement instead, so we're only going to do it conditionally depending upon what the constant is that comes in, and the constant will be changing depending upon what the key press is. Let me go ahead and switch out, grab the code for that from our handy page here. Switch back to here. I'm going to replace this whole line of code because we have it already there. So now you can see that the register changed from being C1 to C200, and in general we'll go ahead and use our own constant from now on instead of trying to find ones that are already there, because it's easy enough to define our own, and we have other reasons to define this constant, including this magic number here for the stereo texture. We'll get to that shortly. So we're going to use C200 dub, just a 0. Same principle as before. If we assign 0 to the output color register, then the color goes blank and we have an invisible effect which disables it. Okay. So now the way this code works as it comes in is we get a constant coming in from C250, constant 1, and that's going to be in the X register. That's the same thing as constant 1. Now we assign that to this temporary register, R30.X. There's no particular reason to use R30. We can use any number from 0 to 31, but we like to use nice round numbers to make it clear that it's our code instead of their code. So just a convenience. So now what we're going to do is we're going to assign whatever the value happens to be for that constant at that moment in time into R30, and we have to put it into this temporary register as part of the assembly language requirements, as opposed to doing two comparisons of constants back to back. Then we're going to compare this R30 that we just made, and we're going to see is it equal to, the if equal to, C200.x, which is our C200 constant that we defined, and the .x in this case is 0. So the principle is the constant 1 coming in equal to 0? If it is, then we actually want to execute this instruction, which is our disable instruction, the move. If it's not equal to 0, then we want to skip this instruction, and that will leave it as the default, which is what actually got executed here. So we get our effect of only disabling it if the number is 0, which is false, and we want to leave it turned on if the number is 1, which is true in Boolean logic. I hope that's clear. If that's not clear, please don't hesitate to ask us questions. If you work through this logic, I'm sure that will be a little bit clearer to you. And in general, what we try to use is we try to use what they call positive logic as opposed to negative logic. Negative logic is double negatives, which when you're reading code, it makes it difficult to understand. So in this case, it's positive logic. Only do this operation if it's a 0. Okay, so that looks good. I think we're ready to try that particular operation. So I'm going to go ahead and save the file. Make sure this guy is saved. It looks good. Okay, that's everything that we need for the actual code. So let's go ahead and run the ball and see if it works. Go ahead and hide those guys down. Okay, here we are in the mighty ball again, and it doesn't look like it's working correctly. Initial expectation was that this effect would be off. By default, we're passing in the 0 constant unless we switch the key, and so I would expect this effect to be disabled to start with and then only show up if we actually press the key. But nevertheless, let's go ahead and try and press the key and see what happens. Okay. That's definitely not what we were expecting. Expecting the ball light, this bloom light, to actually be disabled and come back on. But you can see that it's affecting some other shader, which is not the one that we thought that we were editing. And in fact, that shader is definitely not the one that we were editing before. So something is definitely off as far as that goes. Now, having noted that, you can see that our if logic actually works quite nicely because we are getting a toggle effect as I press the key for off, then back on, then off, then back on. So the toggle is definitely working. It's just affecting the wrong shader. So very interesting. Let's go ahead and quit the game and let's see if we can see what might actually be causing that sort of a problem. Okay, so back at the desktop after having quit the game. So now, normally I would snip out these sort of glitches in the system here because they tend to be long and tedious to find out what the actual answer was. But I think that it's actually highly instructive to see a failing case as well as the success case. This is a perfect example of a failing case where the shader that's being affected is not the one that we thought we were actually affecting. And so I think this might actually be a good moment to take a little detour and try to figure out like what actually is happening with the shader that we are looking at, and to show you some way to approach these sort of problems and what you might do to actually fix it. So we'll forge ahead and take a look at this. So here's our shader that we had. Everything seems to be working okay, including our logic. We're definitely getting the key press logic, so it's coming all the way in from the DX9 settings. We're getting our constants passed in like we'd expect, and in fact, actually, we are disabling the effect as we wanted. Now, the fact that it's affecting a different shader suggests that we have some sort of a conflict, and this is one of those things that happens with the HelixMod, and that's why this is sort of interesting, is there appears to be a conflict with the one of our constant registers here and something in the game itself. So if you run into this sort of a scenario, the thing to do is to try different constants and see if you can figure out something that doesn't conflict. So in this case, what I'm going to do is I'm going to go back to the ball binary folder here. So now this is where the dumps folder comes in handy. So now in dumps, we can actually search for C250, which is the register that we're actually using in this case, right? We've got our 250 that's actually coming in from the dx9 settings.ini file, and you can see that in fact there is a shader that's in the dumps somewhere that is actually using that constant C250. So opening that up and taking a look, we can see that sure enough, here is one of the shaders who's actually using C250. Now, I don't know for a fact that this is actually impacting our results, and the theory is that this particular local constant should have no impact on our global constant, but the stuff is complicated and there's no guarantee that we're going to get what we want. So this is one of those where we just have to try things until we can get it to work. So I've already tried this experiment, so I'm going to show you how how to fix this particular problem, but I think this is probably where our conflict comes from, is that constant's already being used. So we'll go back here. I will edit these up and make it a little bit cleaner later, but we're going to go ahead and change this constant number, the one that we pass in, we're going to change this to 220 instead. And while we're at it, let's double check and make sure that C220 is not being used by anyone. And then now you can see that there's no conflict in dumps, so that seems like a slightly better value to use. Okay, so I'm going to go ahead and use C220 in this case. I'll change the constants to like make this match. So C220, because if the comments don't match, then things get very confusing. So I'm going to go ahead and find all the uses of that word C220, which is this editor is nice for doing that sort of thing. And that looks good. We're still going to use const 1 because I don't think that's related, but it's always possible that we have to switch to const 2 and use the y parameter instead of the x parameter. There's been some discussion that that would actually be the case. Okay, so I'm going to go ahead and save that guy. Now we're going to switch back to our shader file. So now instead of this being C250, it's now C220. And now you can see one of the reasons why I like to have the comments in here so that I can keep track of things when they start going south and then keep changing. If you have to keep reading this all the time, it gets on the crazy side. But be sure to keep the comments up to date with the actual code. Okay, so C250 is here. We're going to go ahead and change it. Now it's C220. So now we're back to the same logic. C220 comes in. It's const 1, gets put into R30. So we're comparing our number, C200, which is the 0, to the C220, number, which is going to be 0. And if it is, we're going to go ahead and disable the effect. Okay, save all. We are ready to give this another try. Here goes nothing. Okay, now we're talking. So immediately I can see that the effect has actually been disabled, which is what I was expecting before, and no other side effect like that sort of haze plus fog was changing when the shader wasn't working before. Okay, so now I'm going to hit the key, and there you go. Look at that. Okay, so now we actually have it working properly the way we wanted it to all along. So numpad 0 disables our disabling, I guess, which is a double negative. That's why we don't like that sort of logic. So it's on or off based on the toggle for the numpad key 0. So there you go. So this actually works now with that change in the constants. So we'll go ahead and use those constants, and I'll put the code there so you don't actually have to edit that. It'll be set up correctly when you see it on the web page. Okay. Hope that all makes sense. Hope that's not too confusing, but that's the nature of the beast. We are definitely going to run into this sort of thing periodically where there are conflicts that actually come from the game. Going to go ahead and exit the game there and go back to our page. And we got it working after a little bit of work, but now we're actually done with that section. So I hope that gives you a good starter for how constants work and how to actually use them in the code itself.